This is a bike-powered plastic shredder. I've been teaching robotics for over 10 years, and every year, it's the same story. We design a part, we print it, doesn't work, and we gotta print it again. There's always one thing that's bothered me the whole time, is the amount of waste that we end up creating. Every iteration, every prototype that didn't quite work, every part we printed usually starts to pile up. And my students and I wanted to do something about it. But more than that, I wanted my students to actually feel and understand why plastic recycling is such a hard problem to fix, and I didn't want them just to hear me say it. So we built a bike-powered plastic shredder. Our goal was to take down all those prototypes we were making, filter them back into plastic, so that we can then turn it back into 3D printing filament to print things out of again. Now, here's the thing about trying to recycle plastic. It's hard. The infrastructure is patchy, most plastic doesn't actually get recycled, and the feel-good claims that some companies often have very little actual recycling behind them. And I really didn't want to greenwash this project. I wanted my students to build something that was real and at the scale where students could really actually see every step of the process and ask some real questions about it. Oh, and this bike was donated by a local school in the area for neurodivergent kids that runs a bike shop and they repair bikes. It's a nice fix considering that we're giving a second life to plastic being powered by a second life bike. And I mean, we're in the Netherlands, which bikes are basically part of the city infrastructure, so it really would have been weird to not use a bike. Let me take you through how this thing actually came together. The design started from an open source shredder from Delft University, and it's part of the Precious Plastics project, a startup which plans to show people how to recycle plastics at small scales. The shredder's a great design. And the bike design from Delft is pretty great too, if you're adults in a workshop and not students in a school. And I wouldn't really call this design safe for use around kids. So we iterated on their design. Now this is the Precious Plastics Shredder 3.3, which we purchased laser cut through a local company in Spain. The shredder works by rotating these big blades that interlace between these fingers. Plastic gets fed into from the hopper above, gets grabbed by the blades, and then it's torn apart between those physical sections. And as plastic gets moved around, there's a small sieve in the bottom that allows pieces about a 4mm diameter through, and these drop into our hopper. And it's perfect shreddings that we can then turn back into 3D printed filament later. Now, one problem with the Delft design is that on a really heavy push on that bike, this whole shredder wants to tip forward because it's not actually physically mounted to the bike. And the torque loads are serious enough that we can actually tip this whole shredder over. And this shredder itself weighs almost 20 kilos or 45 pounds. And that's not really something that you want to have a bunch of flying 45 pounds of steel coming at you. So this huge frame made of aluminum extrusion really helps keep everything from falling apart. Now, a human on a bike produces about 100 to 200 watts at a comfortable pace. The shredder needs a lot of torque or rotational force to be able to grind up some of that plastic. So the entire drivetrain on this bike is designed around a massive gear reduction. And that's where this thing comes in. This is a 75-tooth sprocket, and it's absolutely absurd. It's completely necessary so we can actually generate the amount of torque we need to shred out that plastic. That size difference between the sprocket on the bike and the sprocket on the shredder is what converts your legs spinning into enough torque to actually tear that plastic apart. So the output is about 5 times slower than the input, but it has 5 times the power. To safely get this plastic into the shredder, we built this hopper. It's basically a funnel that feeds the plastic down into the blades. So basically, we can drop plastic in, keep it contained, and keep those little hands out of reach while it's in motion. The extra shredder starts about here. And we laser cut it out, we did a little bit of 3D printing, and made some little acrylic windows so that students can actually see the shredder in action. And then there's a flywheel. This is about 15 kilograms or 33 pounds steel disc, and it exists for one reason. Shredding plastic isn't a smooth load. The movement is chunks of plastic fill through the blades. The system suddenly takes a hit, and without that stored inertial energy, it can really stall fast. So that flywheel keeps us spinning through those impacts, and it kind of smooths out that load through the whole system while it's staying alive between the pedal strokes. It does get hung up on some huge pieces occasionally, but it really does help a lot. We had ours cut out on a water jet from a local supplier. Now it came to us rusty, so before it went anywhere near that machine, we cleaned it up and we gave it a little paint. Now most of the hardware, the shafts, the bearings, sprockets, chains, aluminum extrusion, came from a company called Masumi, and a huge shout out to them for supplying the project. They basically had every part we needed to build this, and having parts that are actually specs correctly makes a huge difference. Now, everything on the shredder mounts to an aluminum extrusion frame, and most of it is 40 by 40, but some of it's a lot bigger. And this stuff is clean, it's modular, and it's strong enough to handle the amount of torque loads that we knew were coming through this shredder. It uses lots of different blind nuts to put it all together, some different T-nuts. Now, I'm assuming we'll ship these out with both ends tapped. I definitely forgot to order it with both ends tapped. I only had tapped on one side, so I had a ton of M12 bolts that I ended up having to tapping here. Oh, and we used thread locker on just about every single bolt. Once the frame was together, we did a first test fit, and there was a problem. Now, the shredder looks great, but it's spinning backwards. So we took it apart, flipped it around, put it back together. Working fine, and now it's time to mount the flywheel. We got 15 kilograms of steel, and that needs to be mounted pretty carefully. It's got to be balanced, it's got to be positioned so that the chain drives it, everything cleanly, and things move downstream without any issues. And I've got these little steel plates on the side with a little dual bolt system that allows me to adjust the size of that wheel pretty easily. And with the flywheel on, we can finally run chain through the bike and up to the shredder. And this is where the whole drivetrain actually comes together. Bike to flywheel to shredder, all linked together with some chains. And it turns out my chains are too short. Now, fortunately, Dutch schools typically have bike graveyards. Got ourselves a donor bike, stripped for the chain, got what we needed. And thanks to building this all in aluminum extrusion, things can be slid all around wherever you want, so they can basically be wherever you need them. But shortening things up also means this 45 angle bracket is a little too long, so we need to cut it down. Brought it home to my shop, slapped it down on a big bandsaw, and then a little quick cut, and we're good to go. During my first real test, the chains kept jumping off. Tension wasn't right, and I had to swap things around a little bit. But now the chain finally is tight, so it shouldn't slip off this time.
No slippage. We are turning.
It looks pretty good. Swap the chain configuration, figured everything out, and got it working on running chain. And the last thing to do was the acrylic shielding around the drivetrain. Mostly for safety to keep hands away from this gigantic spinning saw blade, but it also doubles nicely so you can actually see what's happening on inside. And then it worked. Now, the first real run with plastic, and the gear ratio is really doing it what it's supposed to do. And this thing is pretty fantastic. Honestly, it works a lot better than I was expecting. Sometimes it hangs up, but for the most part, pretty good. Now, one thing I was genuinely nervous about was the size of this flywheel and being able to slow it down. Because the amount of rotational inertia that's really present in there, I was concerned I might not be able to stop it. But even if you give this thing a good go, it really takes nothing to be able to stop it. So my fears were really kind of unfounded on that one. So what's our next steps then? So we've got a bunch of little plastic shreds, but what exactly do we do with these little parts? The whole point of shredding this plastic is to eventually turn it back into 3D printing filament. And we're working with a machine from a company called ArtMe3D on that next step. It's basically a machine that can take these little plastic shreds and then melt them down and turn them back into some 3D printing filament. Now, Stefan over at CNC Kitchen's got a great video on that. I'll have something in the future, but he does a great job at testing just the reliability of recycled filament, how the machine works, and that's basically what we're working towards. But here's the thing. This really isn't designed or meant to be a perfect machine that saves the world for recycling. It's really meant to be a fun teaching tool, and it's done exactly what I wanted. Students get to see every single part of the process. They understand why that gear ratio matters, why that flywheel exists, and why recycling plastic at any sort of scale is genuinely complicated work. There's no greenwashing and no magic put in a recycling bin, and all of a sudden the mysteries of the world are solved. This thing works great, it just doesn't look great yet. There's still quite a bit of finishing work to do. I got to do quite a bit of more shielding around here because this giant flywheel is effectively a large saw blade. I need to do some better changing around the chain guard because this is just scraped off another bike with some zip ties. And then I also need to put in a little more acrylic sheathing around with some nice 3D printed mounts just so that this thing stays perfectly safe. Another thing I have to do is right now you can see that the whole bike wheel is able of just freely floating. So I need to put a quick little mount on the front of that thing so that it doesn't roll away. If you want to build one of these for yourself in your community, I got the full CAD model down below, and I got a full build of materials as well for everything you'll need. And again, a huge thanks and shout out to Misumi for all the different hardware for this, for Precious Plastics and Delft for open sourcing their designs, and then also for the school that donated the secondhand bike. In the future, I'll probably also post something on when I actually get around to designing and printing that ArtMe 3D filament maker. And if you ever happen to be in the Netherlands, swing some PLI by and we'll shred it down together.